All right, so we're continuing with logarithms, guys. And what we're talking about today is logarithms in base E. Now, I've written a bit of a description about what E is here. And you don't need to know so much what E is. E is a number. It's a bit like pi. It's what we call a transcendental number. And it's approximately equal to 2.72. Okay? So for us, we're just going to use it as a number. If you're interested in where it comes from, I can send you some videos on that and so forth. But for now, E is 2.72 and it's a number. What we're looking at then is the logarithm in base E. Okay, we've looked at logarithms in base 2, base 3, base 5. Now we're looking at logarithms in base E. So that means the base is 2.72, right? And we call this a natural logarithm. The way we denote it is ln for logarithm natural, not natural. That's Latin. All right, and the same rules are going to apply. It's just going to be notated a little bit differently. So we have ln e to the x, we'll simplify to x. We've expressed this as a single power of e. Same here, e to the ln x will simplify to x as well. The way we get rid of ln is by applying e. The way we get rid of e is by applying ln. So here if we have ln e to the 2.2, it's a logarithm in base e expressed as a single power of e. So it's going to simplify to 2.2. All right, ln e to the x on 4. Again, logarithm in base e. So it's going to simplify to x on top of 4. In C, the only thing we're going to need to do is use index laws to express it as a single power of e. So at the top I've got ln e to the x, and at the bottom I've got the square root of e, which we know is e to the half. Right? The square root of e we can write as e to the half. That will be then the top power take away the bottom power. ln of e to the x take a half. I've expressed it as a single power of e. So now it simplifies to the power of x take half. In D, we have e to the power of ln 4. So just following this rule here, if e to the ln x is x, e to the ln 4 will simplify to 4. All right, now, just like with logarithms in base A, if we have 2 ln 3, all right, I'm just focusing on the power there, 2 ln 3, one way we can write that is ln 3 squared. Okay, we can take that number out the front and make it the power. Remember how we did that with logarithms in base 10 and base A? There's a number out the front, we can raise it to the power. That's the third rule listed above with your examples. And that is e to the ln 9, excuse me, equals e to the ln 9. 3 squared is 9, right? And now we've expressed it like this, e to the ln x is x, so e to the ln 9 will be 9. Okay, so I'll take you through that one again. What did we do? We've got e to the 2 ln 3. We take the 2 to be the power of 3. We move that around there. 3 squared is 9, and then e to the ln 9 simplifies to 9. All right, here we've got ln e to the a times e to the b. Let's express that as a single power of e using index laws. That's going to be a plus b. We add the powers together. We've expressed it as a single power of e, so that will simplify to a plus b. All right, another go at question 2 here. We've got write in the form e to the power of k, where k is correct to 3 significant figures. So if we have the number 4, and we want to express that as e to the k, all right, we want to express it as e to the something. What we're going to do is we're going to take the natural logarithm of 4. We're going to find ln of 4 and evaluate that in our calculator. So, who's got one back? Can I bring more? So ln, can I tell you where the ln button is? So the ln button is pretty much in the middle of your keyboard. It's right next to sign, right? And so we're just going to type in ln4, and I've got 1.386. So I've written 4 figures. Let's round it to 3. That's going to be 1.39. So we've found ln of 4 is 1.39. What this means is e to the power of 1.39 will equal 4. So we have the logarithmic statement. Ln of 4 is 1.386. Therefore, e to the power of 1.39 will equal 4. All right, similarly with the next one, we have 216. So that's 2a. All right, I'll clear some space. And we'll do 2b. We're going to do ln of 216 in our calculator. ln 216. I've got 5.375. We'll round to 3 figures. All right, so we write 4, round the 4th one. And so what does this mean? It means e to the power of 5.38 will be 260. All right, so that's question 2. And then on to question 3. ln of x equals 2. ln of x equals 3.41. Okay, now we're solving logarithmic equations here. Remember, we saw, we've seen in the past that if we want to get rid of a logarithm in base 10, we raise 10 to the power of both sides. If we want to get rid of a logarithm in base 2, we raise 2 to the power of both sides. Here we have a logarithm in base e. So that means we're going to take both sides and raise them to the power of e. Excuse me, that should just be e to the 2. All right, so both sides are equal, and I've done the same operation to both sides, right? I've raised e to the power of ln x on this side and e to the power of 2 on this side. Now, e to the power of ln x, what does that simplify to? X. So the left-hand side is x, and the right-hand side is e to the 2. Okay? So the solution to this equation is e squared. ln e to the 2 is 2. All right, similarly with this one, we'll put e to the power of both sides. That allows us to get rid of the ln, and we've got x is e to the 3.41. Maybe just to demonstrate how obvious that is as well, we have ln of x, right? ln of x, and so that would be ln of e to the 3.41, and using the rules we've seen, ln of e to the 3.41 would simplify to 3.41, right? So we've got ln e to the 3.41 is 3.41. So just demonstrating the veracity of what we've found there. And the very last one, we've got to show that. So we've got ln of 1 on 36 equals minus 2 ln 6. So we need to demonstrate that this is true. So we're going to start either with the left-hand side or the right-hand side, doesn't matter. This time let's start with the right-hand side, and we're going to manipulate it until we get the same thing we have on the left-hand side. In fact, maybe we might even do a bit of both, and then I can show you like the multiple ways of doing this. So the right-hand side is minus 2 ln 6. We're going to express that as ln 6 to the power of minus 2. All right, so we're moving this number out the front to become the power on 6. Okay, now one thing we can do is, like, we haven't proved it yet, but let's say we got stuck here and we weren't sure what to do next. What we'll do, we'll jump to the left-hand side and let's have a wrestle with the left-hand side. On the left-hand side, we have ln of 1 on 36. All right, one way we can express that is ln of 1 on 6 squared. And one way we can express that is to take it to the top and make the power negative. And here we've demonstrated that the left-hand side and the right-hand side are the same. We've processed the right-hand side a bit, we've processed the left-hand side a bit, and we've shown that they're the same. So with these proofs, all right, you can just take the right-hand side and keep manipulating it until you get the left-hand side. You can do the opposite, take the left-hand side, keep manipulating until you get the right, or you can manipulate both until you get to the same answer. All right, we've shown that they're the same here. They're both expressed as ln of 6 to the minus 2. So there's lots of ways of doing them just using index laws and the laws of logarithms. So this is enough for us to have a bit of a wrestle with exercise 13D.1. That's all we're doing for today's lesson, natural logarithms. By the way, E, it's called Euler's number. It's spelt Euler, but we pronounce it Euler, German mathematician. Yeah, I think that's all we need to say. So you don't need to know the mathematical